Well, hello everyone. Welcome to part 3 of my tutorial of coding DLL injection into all processes. And today we will continue where we left off, coding a Windows driver. So let's go back to our host machine and coding environment. We will be using Visual Studio 2019. Here's our inject all project. Make sure to watch previous parts just to see where we left off. And basically, we created this just basic, very simple scaffolding with driver entry that loads and then unloads, and just simply outputs 2 messages into debugger console. So really simple. So let's expand it a little bit more and actually do something useful. Well, first of all, we need to save the driver object. And the reason we would do that is so that we can actually use reference counting to keep our driver loaded in the system. So to do that, let's go all the way to the top and let's define some area for global variables. We won't have too many of them, but we will have some. Now, I will declare it as a C object, and the reason I'm doing this is because a lot of, not a lot, but some of the code will be written in assembly language, and that will be easy way for me to access it. And I will explain this later on. Okay, so I usually give my variable names prefix g underscore if it's a global variable. It doesn't have to be done, but this is just my, I guess, my way of doing things. I just got used this way. And this is a read only. And we need it for reference counting. Now, reference counting is a method of keeping a kernel or pretty much any other object in memory, and I will explain how it works a little bit later. Now, right now, all we need to do is just to fill it in when we have it, and we have it right here. So we do driver object. So that's pretty much all we need to do here, and at this point we can actually use our API. If you remember in part 1, I showed you this API, which sets up a callback for any module that is loaded into any process. So, well, let's try to set it up. Let's just say set image loading notification routine. So here's our API that takes only one parameter, which is our notify routine. And if you look at it, it returns NT status. So let's do that, NT status, and this is status. And we can also return it from our driver. So obviously, if our API fails, because our driver entry procedure will be really simple, all we need to do is just call this function. So, and if it fails, well, first of all, we need to check. And I like to use NT success procedure. I mean, not procedure, I'm sorry, the macro. It's a very simple one. So if you look into it, it just checks that the status is, NT status is greater or equal than 0. So if it's success, we need to process it. Otherwise, we have an error. And we can use our debugging routine to actually output it. And what I usually do, I write, well, obviously critical, because our driver is not going to run if that function failed. And then we output the status code, which will be very helpful. And then I put the API. Now, this one is not a production project, and the reason I'm putting it this way is so that it's easy for me to know which API failed and with which status code. And that's what we get here. And in this case, if we actually succeeded, we need to keep track of this so that we can actually, when our driver unloads, we can actually know that this took place. Now there are many ways of doing it. I personally like to use a another global variable. And before we do that, let's go into types and define a special type. And let's use an enum. Let's just call it, I don't know, image load flags. Now in this case we have very simple flags here, which would be, I don't know, image notify set. And what we'll call it, if this flag is set, again, it would be nice to provide some kind of a comment here. When, let's see, this routine was enabled, right? So when this is enabled, we will set this flag. And the way we would do this is that we will define this as a global variable. Let's say here, and we call it G flags. And let's just say global, well, notification flags. Now originally it will be 0, and what would happen when our procedure succeeds, we'd use intrinsic, which is called bit test and set. Now we don't need to test, we need to set it, and we need to set it with this bit number. Now what this thing does, and by the way, that assumes that we have a long parameter here. So if you look in MSDN, this is one of the intrinsics that basically translates into CPU, into atomic CPU instruction, and it sets this bit number in this variable, and then it returns, but the return value doesn't matter for us. But basically it sets this bit in this value quite not quite atomically, but atomically, so that if there's a second thread that checks it, the operation will be atomic. Okay, so at this point we have an error here because we didn't specify our routine, but what we can do next, we can actually set up a function that will unload it for us. But for now, let's specify the actual routine or the callback. So if we go back, we have this image loading routine. So let's do that. So the way we do this, I personally like to just give it, you know, some generic name, something, not generic name, but something that I would understand, and I would call it OnLoadImage, you know. And then what we can do, I can just copy and paste it from here so that we don't have to type all this stuff. And let's put it here on top. And let's make it into a function. And let's give it this name. Now to make it more legible for people that might be working with this, let's just give a little description for this function. I like to do this so that, you know, the person that works with this code after me should be able to actually understand what this is. Okay, so this is a callback notification that an image is loaded or mapped in memory, right? And what's interesting here is that obviously it's image name, and the process ID is the process where the image is mapped into. It can also be 0, which is kind of like unusual for a driver. So if a module is loaded into the system process or the driver itself, the process ID will be 0. Okay? So this is the actual function where most of the work will be done. So let's leave some space for it, and let's see if it builds. And we have a problem here. Oh, we have, again, unreferenced parameters. Let's make sure that we add our macro here for all 3 of them before we actually started using them. And let's see if it builds. Okay, and it does. Now we can't really test this because we have a memory leak. So you can see we use the registration callback. And if we look back into the API itself, we have to call remove notify routine. Now for now we don't have anything to remove it, so how about we actually write it? Let's see. How about we put it right above driver unload, and like most kernel functions it will return status, and let's just call it free loaded image. You know what, that's not a good name. Let's just say free resources, and let's say free our resources must be called before unloading the driver. Okay, obviously it returns a status, so let's just do this status, and originally let's just say status success. If we don't do anything, it will obviously return success. And let's just call it from over here, from our driver unload. Right, so we get our status and then we report it back. And let's see, now the first thing that we need to do, we need to remove the notification callback. But we need to do it only if it was set before. Right, so if for some reason we don't have it set, we don't remove it. And the way we test it, we call another intrinsic function which is called bit test and reset. So it kind of does 2 things at once. It tests our bit here that we set here in D flags. You know, we can just copy all of it and paste it here. So what it does, it tests this bit in this value in flags, and if it's set, it returns it, and otherwise it clears it. That's pretty much what it does. It's kind of like an intrinsic operation. So if that bit is set, we can actually call this function, and let's see, it returns status, and then we need our notification routine, which is very simple. It's this one, and then we need to see if it failed for some reason, and the way we check that is -2, opposite of NT success. And you know, it may fail for some reason, you know, you never know. And let's put another print line, so I'm just going to copy and paste here. And here we would do another critical, and in this case we need to change the function name. And now we have our routine that will be removed normally from the driver when it unloads. So let's make sure it builds, and it does. So at this point we can test our driver. Now at this point there is not much going on here. So let's not waste our time. Let's just add a little bit more into our OnImageLoad, and then we'll actually run the tests. Okay, well, this OnLoadImage will be the callback that will be used the most. So we will probably need NT status. Well, let's just create it first. It's more like a habit when you code in C, even though we're not coding in C, but I kind of got used to just declaring all my variables on the top. But obviously you don't need to do that. So, okay, well, let's remember our strategy. So let me bring that ugly diagram that I drew for you. So if you look here, this is pretty much the sequence at which modules are loaded into the process. So first we get the PE itself, the executable file. Then we get NT-DLL, and the third one is kernel32DLL. And that's the DLL that we will be intercepting. And when it actually comes in, we will be injecting a fake DLL into it right before it. So that's kind of like in a nutshell. So let's try to catch that moment. So what we're going to say here, we are looking for kernel32DLL only, skip the rest. So how do we do that? Well, let's define our scope here. Well, first of all, we need to make sure that, let's just do it right here, that image info is not null, because we will be using it, and that we have full image name. By the way, assertions are very interesting, kind of like nice debugging tools. It's a macro that will be converted into RTL assert only in debugger configuration. So if we do release and go back and try to peek definition, it will be just removed. So pretty much anything inside the assertion will be removed in release configuration, which is pretty easy for us. So what we're doing with these assertions, we're just making sure that these pointers that we get here are actually valid. Okay, because if we're not, we get a bug check over here. Okay, so the first thing we need to do is to see that this is not a system image, because if it is system image, there's no point in testing it. So let's just say skip anything mapped into kernel. Okay, now the second thing we need to do, we need to make sure that our process ID is the same as the thread ID that we're running in. Now, you would think that would be a given, but it is not, because our section can be mapped remotely into this process, and we don't need this. Let's just write a little comment here. Our section, and by the way, I'm using the word section and image here, or DLL, interchangeably. If you remember my diagram here, they are kind of the same thing. Okay, so if our section, it can be mapped remotely into this process, and we don't need that. Okay, so this is kind of important, because we don't want to waste, don't want to do this if somebody is doing this remote mapping. Okay, so at this point we just eliminated simple situations. Well, the next one, we need to check if our image name is actually kernel32. Now for that we need to write a small helper function. So we need to go into C functions and actually write it. Let's see, where is our class? And it will return a boolean, in other words, yes or no. and it will be called IsSuffixedUnicodeString. Now what this means is that is Unicode string ending with another string. And what we will be getting here is a pointer to Unicode string, which let's just say will be full name. Then we will have a pointer to another constant Unicode string will be short name, and the boolean, let's see, boolean will be case insensitive. Okay, so let's write what the function does. Check if full name check if full name ends with short name. That's what I abbreviated here as suffixed. And case insensitive, let's say true to check in case insensitive way. In other words, ignore case or ignore case, ignore letter case. Okay, and return, well, return is simple true if yes. Okay, so we need to do a couple sanity checks that the full name is valid pointer, that the short name is a valid pointer, and that the short name length is less or equal than the full name length. In other words, if the short name is longer than the full name, then there's no way it can be suffixed, so we just skip it and return false. Okay, and inside we can use an API RTL equal Unicode string. So it takes 3 parameters. It takes, I'm looking at the IntelliSense, it looks at string 1, string 2, which will be short name. Oops, let's see, short name. And the third value is case sensitivity, which is this one. And now we need to create another Unicode string that will point to a portion of our long name. So what we do here, now if you look at Unicode string, first we have length, then maximum length, and then the actual pointer to the buffer. So the length is the length of the short string. Then we just copy it here. And then we use a macro offset to pointer. And we need to convert it with like explicit cast. Okay, and then we have full buffer. In other words, we kind of look in the full buffer, and we have full buffer length here minus our length. So in here we basically skip the length of our short string from the beginning of the buffer in the full name. Okay, and then we pass this Unicode string as a parameter. So what we need to do here, we need to add this as a static variable into our class. Now it has to be public, and by default we will be assuming that everything is case insensitive. Okay, so at this point let's try to compile it, and we have an error here, and obviously yes, status is unreferenced, so we'll reference it later. So at this point, what we can do, we can actually look at and we can actually use our function. Okay, so our next test here, let's put another and here, and we need to see if the full image name is prefixed here. And let's keep this a little bit over this way. And we need kernel 32 DLL only. Okay, so now we need to define kernel 32 as a Unicode string. Now, before we go any further, I want to create another helpful macro that came from my friend, and he came up with a really neat solution to define these static Unicode strings. Now let's go into driver types. I'm going to copy and paste some code because I just don't want you to, see me type all this stuff, and then I'll explain what it does. So in driver types, I'm going to add this stuff. Now, what this is, it basically defines some way for us to define static variables, static Unicode string. The way a Unicode string is defined is that you have to add all these into the structure itself, into the Unicode string structure, and then also create a couple references to it. And it's kind of like cumbersome if you have 3 lines of code basically going for just one thing. And what my friend here, what he did, he basically simplified it so that we can just do this thing instead, which is very helpful. And then he also did the same for static object attributes, which is kind of like another structure that we will need further on. So now we can use this macro to define our kernel 32 as a file here, and then we can just do this. Fortunately, the screen is too small, so I'm going to align it this way. And let's see if it builds. Okay, again, unreferenced variable, but that's fine. So at this point, as you can see, we are capable of checking if the full image name actually ends with this. And what this means is that the image name will be, the full path to the image that is loaded, and we get it from over here. And then we just need to see that the file is actually kernel 32 in case insensitive way. So that is how we can tell that, hey, this is our DLL, and this is our needed DLL, and we need to proceed. Now, there is additional caveat that my friend RBMM found in this case, and that is when the section can actually be mapped through an API. Now, there is an API, which is, let me just paste it here so you can actually see, which is called map view of section, that can also map a section or a DLL. Well, in this case, if it's mapped this way, we don't have to process it here, because obviously that's not what we want. We need to make sure that our DLL comes from the actual function, which is LoadDll. Let me just point it for you. Now, this is a undocumented function, but this is basically NT API that is called when the DLL is loaded. Now, it's undocumented, but basically load library would call this API internally from NTDLL. So we need to make sure that our call here comes from this function and nothing else. Now, this is totally undocumented and totally kind of like reverse engineering, but we kind of like came up with a solution that I will code in this function. So in other words, we need to define a function to tell if our image came from load library. And the way we can do is through another helper function. So let's skip down here a little bit. It will also return a boolean, and let's call it IsMappedBy, and then the name of our loader, LoadDll. Now, as an input, we'll have pointer to a Unicode string, and it's a short name here. Now, instead of typing all this stuff, I'm just going to copy and paste it. I pre-wrote it. So basically, we're seeing if this short name, the module, came from this function. And this might happen if it might not happen if we got this from calling this API. So in this case, because we are dealing with unknown memory pointer, we need to actually envelop it into try and except block, and here we will catch let's see, exception execute handler, and then we can say that something failed, and in this case we're just going to say print line, and we will say exception. We'll put exception code and put the name of the function and get the code. It's just another macro. Okay, and at the end we will return false if we get to the end. And then let's write the logic for this function itself. So at first, we need to get the actual pointer to so-called TEB. This is a thread environment block that we will be using, and the thread environment block has a special, well, undocumented parameter called arbitrary user pointer that is set by this API. So let's do this, and we need to get current thread TEB. And we'll do the cast here. And then what we need to see, well, did we get it? If not, it's, obviously not going to work. And if arbitrary pointer is 0, then this is not it. So we return false. Now this is undocumented, so you can kind of search, but basically this API will set this parameter to non-null, and that's how we can tell. So this is one check. Then let's define a Unicode string variable. Let's call it name, and we need to fill it in. So the buffer, need to do like explicit cast like this, is the actual parameter here, and it will contain the name of the module if we are using loader LoadDll. Well, because this name might come from anywhere else, and because, well, the TEB itself might actually not be coming, we might be coming from some other API, we need to do thorough checks here. So we need to check that we have a valid user mode address. Now obviously loader_load_DLL is a user mode function. Well, we are in the kernel and we need to make sure that not this, but the actual pointer here is coming from the user mode. For this we use an API called probe_for_read, and what it asks for the address, which is the one we just gave it here, and all we need is just a single character and alignment for a UChar. Okay, now if this doesn't succeed, probe_for_read, we will have an exception, so we'll get here. So that's what we need. And it's basically checking that the buffer or this variable contains a user mode address. This is important because if it contains a kernel mode address, if we start reading from it, here we would actually get a blue screen of death. So this is important to call this API. And again, what it will do, if it senses that this is a kernel address or something that we don't have read access to, it will throw an exception that we can catch here. Okay, so if it passes and if we get a valid user mode address, we need to check buffer length, and we can just do length, and we have to convert it into use short, and we can just use a safe API here, and we can go as many as max short. So what this API does, it will check the length and it will go no further than this number of characters. Okay, so and then we can see if we overflowed, we went to this many characters, well, name is too long, so we can't deal with it. Return false. And false basically means that no, this is not a loader_load_DLL, so we don't need it. Okay, and then we need to adjust our length because it's measured in bytes. So we do that, and then we do name, and there's also maximum length, which is just the same thing. And then we need to see if it's our needed module. And the way we can do this is by using our other function, which somehow is not seen here. Oh, I know why. I actually need to add this into our header file. For some reason IntelliSense refuses to work. Okay, so we need full name, which is our name, and here we have a short name, and here you go. So this function will actually return result, which we can return back. So all we need to do is just to invoke this function from our check here. And what we're doing, we need to invoke and to make sure that this is our kernel 32. And let's put a comment here. Make sure that it's a call from the loader_load_DLL function. Okay, so this is kind of important. Let's make sure that we can compile it. And we again have this warning about the status. We'll deal with it later. So at this point we have all of our checks. So if all of this passes, it means that our module is actually the one that we need. Okay, so again we are checking that the module that we have here is kernel 32 DLL. And additionally, there would be one interesting thing to do, and that is to make sure, not to make sure, but to catch situations when we work only with specific process. Now the process ID defines the process. Now let me just, if we go back to the actual test VM, and if we run process hacker, now if you look, for instance, if I go into properties for some process and go into module, so all of these things are modules, right? So when we call this, so when this callback is invoked, now the image file name will be the name of those processes, of these modules. So all of these modules here will be image name, and the process ID, let me switch back, would be the name of the process, no, not the name, ID of the process. Like in this case for explorer.exe, it will be 3120. So that will be the process ID. Now, because we will be testing it originally, and there is a big chance that we will actually mess things up, let's limit, for testing purposes, let's have an option to limit only for specific process. Now, we can't limit by process ID. We need to somehow retrieve process name from process ID. And then we can put a small check here to actually do that. So before we can actually go into this, let's write another helper function that will tell us, that will convert process ID into image name. So let's define it. So it will be a boolean, and let's call it IsSpecificProcessW. W meaning that this is a, it takes a long, not long, it takes wide Unicode string. Okay, the first parameter would be process ID. And again, in kernel, they're called handles. Now the next parameter would be constant wchar, and this is image name. And the last parameter is also boolean, and it is debugged. So let me explain real quick. Now this is a totally a helper function, so it doesn't really, we won't be using it for production. So we can be really generous, or however you want to call it, with it. So we're not going to be too, we're not going to be saving on CPU cycles when we write this, because again, it's just for our debugging purposes. Let's write what the function does. Now it checks if process with process ID is a specific process by its name. Let's say by its file name. All right, so, and let's just specify all of them. So image name is a file name of the process to check in case insensitive way. And this last thing, it is true. We need to set it to true to check if kernel debugger is present. Now, in some ways, in some cases, we might need to know if the system is being debugged. In that case, we would set this last parameter to true, and then it will also check. So this will be handy in case, we need to do that. And return true if yes, that is the process. So we need to do an assertion here to make sure that we have an image name. And let's just do boolean be result, and let's just assume no. Let's return it so that we can compile. And then we can actually use this function. Well, it's not written yet, but let me just show you how you would use it. And we can use it right here. With the process ID, with the name, and let's just say not care about debugging. And let's say for debug build, limit it to specific process only for testing purposes. Okay, so at this point we need to specify the name of the process that we will be searching for. So for that, let's go into our driver types, and here on the top, let's just define a new preprocessor variable. Let's say limit injection to proc, and let's do the name, and well, a well-known process that everybody tortures is Notepad, so let's torture it as well. Process to limit injection to only in debugger builds. Okay, so we have a name, and this is Notepad. So again, we can change it to any other image name, but again, the victim that everybody tortures is a Notepad. So let's do it here. And basically, let's put a couple preprocessor macro checks here. So if defined debug, now we will work on that, and defined our macro, then we do this. Otherwise, we do end if. Okay, now we need to do this debug thing. Now, usually, it's different. Unfortunately, it's different preprocessor name for kernel, and in user land, it's this. So I'm kind of used to it. So just for my convenience, I guess, I redefine it on my own way. So if we go again into our driver types, and let's do some debug build definitions. So if def, and for driver it's dbg. So if it's defined, then we define as debug as dbg, right? And else we don't define it, okay? And also, while we're at it, let's define another macro, which is called verify. In debugger build, it will be equal to assert, and in release, it will be just what we have here. Now, verify would be very similar to assertion in debugger build, but if we change it to release, it will simply keep this function without any assertion checks. Okay, so at this point, let's see if it compiles, and we got a bunch of macros. Oh, obviously these are not used, and that's what it's warning us. Okay, well, at this point we can actually write our function. So what it needs to do, it needs to convert process ID into the image and then calculate it here. And then to compare it to the image name that we're passing here. So how do we do this? Well, let's take a look. Okay, well, first thing first, we need to convert this process ID into eProcess, and that's the internal kernel object that specifies the process in memory. And we can do ps lookup process by process ID, and it takes process ID as an input parameter and returns a pointer to eProcess. So we need to make sure that it didn't fail. And let's see. So basically we are getting this PE process from process ID. What this function also does, it increments the reference count for this process. So at the end we need to remember to dereference process object back. The reason it's doing this is so that the process is not unloaded from memory, and we call object dereference object, and we pass process here. So this is important to do because otherwise you'll lock up this process and it won't be, the user mode won't be able to close it. Let's see, then we need to check for kernel debugger. Now, we don't always have to check that. Now, if this value is false, we don't need to check it. Otherwise, we need to use an API. Now, this is an undocumented API, so I'm going to actually declare it myself. And for that, I'm going to go to my driver types and reserve a section for undocumented functions. Now this is a special section here. I will mark as such. It will be extern C. And basically all the undocumented stuff will go here. And I'm going to copy and paste this one. Now it's has very simple input parameters, basically PE process that it will read, and it will return Boolean. And this is called PS is process being debugged. It's internal kernel function. So let's use it here. And conveniently we have the process right here. Let's make sure that we didn't make any boo-boos here, and we didn't. Again, it's our status from the previous function. Okay, so now we can get process handle. And by the way, the reason I'm doing all this is so that we can use an API which is called query process information. And what this API does, it takes the process handle, and usually it's kind of like a kernel function that is used for user mode when you pass a handle into it. And then if you provide image file name, it will return the Unicode string with the actual image for us. But to make it work, to get to it, we need a process handle, and that's what we're getting here. So we need to get process handle. So let's just call it hproc, and for that we will use another API which is called object, let's see, open object by pointer. So the object is our process, and let's look it up because it's kind of like a tricky function to call. So if we go, oops, actually need to copy it and paste it here. Okay, so we need handle attributes, and the handle attributes would be that this is a kernel handle. This is important because, we don't want to leak it into user mode. So we have kernel handle. We don't need any access state. Now the access mask, we will use process all access, because again it's going to be like a quick access to it. And the type, keep forgetting these, I think it's process type. Let's see, where is it? Okay, yeah, I think it's PS process type, okay. And we are using it from kernel mode and return hproc, okay. So let's break it down into 2 lines, and we need to make sure that we got status success. Again, I'm just reading the documentation. And if we got it here, we need to close the process. This is also important, and we use ZW close, and we specify a process handle. The reason we do this is so that we don't leak any handles here and actually don't create a problem when, you know, this process won't be able to be closed from outside. Okay, well, at this point we can actually call this API here. And so when we call, we need to make sure that this is status success. And before we can do anything, we actually need to provide some input parameters. So it's hProcess. And let's see, information class is process. Let's see, process image file name. And then we need, let's see, what else do we need? IntelliSense is really buggy today for some reason. Okay, process information and process information length. So for that we need UnicodeString. And last parameter is return length, but we're not going to care about return length. And let's specify, well, we need to get process name. And let's see, UnicodeString. Now this API is kind of funny the way they word it here. If you search by this, they want you to provide both the buffer and Unicode string in the same buffer. So I'm not sure if it's a typo, but let's just go with what they said here. Now I want to point out that there is, you know, a simpler API. Let me just kind of like show it here for you, which is called PsGetProcessImageByName. It's undocumented, but let's see if anyone provided any prototype for it. Yeah, basically it just calls, yeah, it just calls the name, it just calls the, it just specifies the handle, I think. Let me just search real quick. Yeah, so let me put like a little comment here. We need full file name, thus can't use which will truncated past 14 chars. So this API will take eProcess on the input and will return truncated file name. Well, unfortunately, many image names in Windows are longer than 14 characters. Even though this API is easier to call, I would stay away from it because, again, it's just not very, it will shorten things. Plus, it uses only ANSI 8-bit characters. So if the file name contains, well, non-English characters, it won't work. So that's why I'm writing a little bit longer version. So, and let's kind of stick with it. Okay, so we need some local buffer. And because it's a debugging function, we'll just use a short buffer, so we'll assume that the name won't be too long. And let's go and create a small definition. Let's see. Well, what I would say is that let's just call get cp function. It's just the name of the function that abbreviated. And what this is, it's a size of Unicode string. It's kind of like the maximum size of the buffer, max path plus 1 times size of uchar. Now this is simply a maximum allowed path, which is Unicode string structure followed by maximum path, which is 256 characters plus 1 for the terminating null, and we need to convert all of it into bytes, so times size char. So this will be the size of a buffer that we'll allocate here on the stack. We'll just go with the easy way because, you know, I don't want to like code it for, you know, with like dynamic allocation and stuff. Okay, so now the Unicode string will be the first thing that this buffer starts from. And let's just do here. And then let's see that our buffer it will begin from the beginning of the buffer plus size of Unicode string, so we'll skip that. And then let's fill in the Unicode string parameter. So length is 0, maximum length is the remaining size, and buffer is our buffer here. And let's calculate the remaining size. Now it will have to cast it into ushort, and we have size of buffer minus size of Unicode string that it starts with. So the rest of it is our available buffer. Okay, so here we can pass this parameter into the function, and we can pass also the full size of our buffer. Let's make sure that we didn't make any mistakes. Oh, well, we don't have this identifier, so we need to include something, so let's do that. You know, I had to pause the video and see where this definition is, and for some reason I couldn't find it, so I'm just going to copy and paste here. Basically you can get this from internet because it's a well-known function. So it takes all of these parameters, and let's make sure that we can compile now, and we can. So at this point we got our name, and I usually like to put a safety null at the end of the buffer. And what we do, we take our buffer, we add size of buffer, so we go to the very end, then we go back by 1 wide character, then we cast into wide character pointer, and we set 0. So in other words, if we have a long buffer, we go to the very end, go 1 character back, and put 0 in there. It's just to prevent any overruns, because, you know, if the function, because this function returns Unicode string, and if the Unicode string is, it might be not 0 terminated, so we need to do that at the end, and that's what we did here. And then we need to also make sure that we have a null terminated string. Again, like I said, because we have a length here in Unicode string, it might not be null terminated, so we need to make sure that that is the case. So we have an if here, and basically what we do is uString length plus size of wchar. We just see if we have any space left for another character. In other words, if we have that, we need to add one last null. And if we don't, well, this line here, line above, basically did this for us at the very end of the buffer. So, okay, well, let's do the same thing. PU string buffer, and let's cast it into byte array, and then PU string and length, and cast the whole thing to pointer to chars, white chars, and put 0 there. Okay, so that will ensure that we have a terminating null at the end. And what we need to do, we need to find file name. Now, this API will return a path, which is also an NT path, to the image. So what we need to do, we need to scan forward and look for all the slashes, and the last slash will tell us where the file name starts, and then we need to return it. So it's just a simple C function, so let's just write it quickly. Let's say last slash, originally null, is just a pointer to track. Then we use for statement, and let's just create some local pointer. Let's just call it PS for lack of a better name. And that will point to our original buffer, and then we'll be incrementing it. Then we will read a character from our pointer. If it's null, well, we reach the end. Otherwise, if it's a slash, then we need to remember it in our variable here. And if we reach the end, if we have last slash, we actually use it, but not just it, but the next character, because it's the last slash, so the character after it, and our buffer becomes this last slash character. Okay, and then at the end, when we actually got the name, we need to compare it to our provided name. And what we do is we use internal function. It's, if I remember, sc compare. Here you go. So we have image name that we got in our buffer, and if it's 0, it's actually equality. Now, image name came from here, and if we got 0, it means image name is the same as this p buffer that we got from calculating the file name. And if we did so, the result is actually true. We just found the match. So let's make sure that we close everything, and let's make sure that result is actually what we want. It's originally false, and if we go all the way here, it is true. Okay, now let's see where our function is used. Okay, well, at this point we have a debugging check, so we can actually get we over here in this long if statement, we can make sure that the module is actually kernel 32 DLL, and we can also make sure that we are in the notepad. In other words, we will skip any other process so that we don't crash the system, and we will get here only in case of our needed module. So let's just write that now. We can proceed with our injection. And just to kind of like see if we, if we actually did everything correctly, let's just put a little debugging output and say image load. Let's just say for PID, and let's provide PID, which is the process ID, so that we can tell. then we can provide, let's see, we can provide a full image name, which is UnicodeString, right? And that's pretty much all we need. So ulong, we have to do double cast because we're casting from a handle, which is a long variable. And here we have a full image name so that we can actually see what image we are injecting into. So let's see. Okay, what will also probably help us is to see if is it a 32-bit process running in a 64-bit OS. Now, we won't need it right now, but let's just kind of prepare for it. And this is called WOW64. We're just going to abbreviate it to WOW. And this would happen only if we are building a 64-bit process. Otherwise, our WOW process is false because cannot be a WOW64 process on a 32-bit OS, because obviously we can't run a 32-bit 64-bit driver on a 32-bit OS, so that's false. But here we just use an API. It's IO is 32-bit process, and well, it's usually using for IRP, but we don't provide it, so it will just use our current thread. Okay, and in this case we can also say that we loaded, and WOW is this here. Okay, so at this point it can actually tell us if it's our WOW process. So let's run it. I'm sorry, let's compile it, and status keeps popping up, so let's comment it out. Okay, and we can actually build. So at this point we can try to test it. Let's make sure that we have everything in check here. So we have a driver entry, which is correct. We have image onload, and we can actually remove it in FreeResources, which is here. Okay, well, so let's build it again. Let's rebuild all. I'm sorry, let's rebuild the solution. And it's in C++. Inject all, x64, debug. I'm going to copy it, switch into my VM, paste it. Let's move it over here, clear our debug view, and let's register and start driver. So here we go, started all right. And let's run a notepad. Let's see what happens. Here you go. Well, it created a lot of noise here. Let's just do it again. Notepad. Watch here. And here you go, image load. As you can see, it's a WOW0, so it basically, it's not a it's a 64-bit process, and we got a kernel DLL in Notepad, and PID is 4704. So if we run process hacker and look it up, 4704, and just to test, let's go into actual 32-bit Notepad. It's located into C, Windows, System WOW64, and let me do search and run. As you can tell, the process ID is 3444. It is 3444, and it's a WOW1, meaning it's a 32-bit process. So as you can see, our driver can detect it correctly. Now, just for the heck of it, by the way, let me do something. If we run it, I'm going to pin it here to the taskbar so we don't have to search for it. And let's see, yeah, so it can definitely do that. And if we run something else, well, I don't know, let's do just calculator. As you can see, the calculator doesn't trigger our message here, which is really nice. And now let's see if we can stop the driver. And it just did just fine. Oh, and by the way, you see the helpful process hacker actually told us that our driver has been deleted. Okay, so at this point, as you can see, our code is working. So we did some basic filtering here in our OnLoadImage. So at this point, I'm going to stop this video because it's getting too long. And in the next part, we will actually do more about injecting of a DLL, well, which is actually, we don't even have it, so maybe we'll actually try to run it. Okay, guys, thank you for watching, and I will see you next time.